This way of looking at things brings us again to the province of philosophy, where there are some standard tools for talking about the causes of effects. One of these is the well-known distinction between the necessary and sufficient conditions for the occurrence of an event. Imagine we have events of type A and type B, and that we observe that when A doesn't happen, then B doesn't happen. For example, in situations where oxygen is absent, we never observe combustion. From this we conclude that oxygen is necessary for combustion. However, there are plenty of situations where oxygen is present, but we do not observe combustion. Therefore, oxygen is not sufficient for combustion. A heavy rain shower will always make my garden wet. Therefore, a heavy rain shower is sufficient to make my garden wet. It is, however, not a necessary condition for my garden to be wet. On a sunny day, I might also turn on my garden hose, and that will also have the effect of making my garden wet. Most events will have many causes, in the sense of a number of non-trivial, necessary and sufficient conditions. Again, there are some standard moves to deal with this. Consider the following case. It turns out that the joint occurrence of events A and B and C, or of events D and E and F, or of events G and H and I, implies that events of type Y occur. It's also the case that if we observe that Y has occurred, we know that either A and B and C, or D and E and F, or G and H and I, or in fact any combination of the three sets of causal factors, has occurred. However things work out, we know that Y is always caused by a set of factors working in combination. If we just look at the first set, A and B and C, we can say that A is an inus condition for Y. That is, A is an insufficient but non-redundant part of an unnecessary but sufficient condition for Y. It is insufficient because to cause Y, B and C have to be present. Non-redundant because without A, B and C will not cause Y. Unnecessary because there are other causal constellations that will cause Y, and sufficient because it is itself part of a constellation with B and C that, if present, is sufficient to cause Y. This way of thinking about causation seems to fit well with our casual intuition. Common sense tells us that there are many ways to skin a cat, not that I'm recommending DIY butchery of pets, by the way, and that it is not sufficient to own a knife. The knife also mustn't be broken, and the knife mustn't be blunt. However, once we begin to identify and invoke multiple causal factors, the question arises, at what point should we stop? A, B, and C are events, which themselves have causes, and these causes have causes, and so on, back to the primordial soup. It's not really possible to answer the "when should I stop" question in a general way. Sometimes features of the context help to identify a stopping point. For example, if the purpose of the investigation is to effect change through a social policy intervention, then it would make sense to stop at the point in the causal chain that is most amenable to direct policy intervention. In the context of a legal process, where the issue of attributing blame is paramount, it is the drinking by the driver of alcohol on the morning of the accident that will be the focus of attention, rather than the irresponsibility of the car dealer in selling a fast car to an alcoholic. The existence of complex constellations of causal factors becomes a pressing problem in small n situations. Typically, these are investigations where the unit of analysis, the cases, are nation-states or some other sort of aggregates. Say, for example, that our aim is to explain the causes of civil wars during the 20th century. Though there are quite a few cases, the number is finite in probably less than 100, the number of potential causal factors is large, even if we limit ourselves just to the more obvious ones. It's possible that we will want to consider almost as many causal factors as the number of cases. Add into the mix the wish to consider some of these as causal constellations, and we have what is called a degrees of freedom problem. In short, we have too little information to examine all the main effects and interactions we would wish to consider simultaneously. Methods based on Boolean algebra and truth tables, which purport to deal with such small n situations, have been developed by Charles Reagan, and a whole style of work, often branded QCA, which stands for Qualitative Comparative Analysis, has popularized the approach that he advocates. I'm not going to discuss this work in these lectures, but should you be interested, I draw your attention to Reagan's two principal expository texts, and to a recent symposium in sociological methodology which subjects the Reagan approach to severe criticism. For what it is worth, my view on the value of QCA is that used with caution it may, in the small n case, be of some use as a tool to help an investigator systematically sift through a complex set of evidence. And, on those grounds, it's probably worth learning about. However, to view it as a machine for automatically turning data into causes is manifestly absurd, as is the application of the method to large n situations. I will now turn to the second of the broad views of causal inference that I want to consider. This is what I called earlier the effects of causes view. In this approach, we're not trying to discover all of the factors that individually and as part of a constellation have a causal impact on an outcome. Instead, the interest is in estimating the magnitude of the causal impact or effect of a single variable, which for convenience I'll call a treatment on an outcome variable. Examples of treatments are a new drug to treat a medical condition, a job training program for the unemployed, an extra year of secondary education, and going to a religious rather than a secular school. In each case, after exposure to the treatment, we would record an appropriate outcome. Though they are not of prime interest, we will of course be concerned about the possible impact of other things, both observed and unobserved, on the outcome. But these will be regarded as nuisance factors that have in some sense to be controlled for. So in short, in the effects of causes view, we focus an intense spotlight on the impact of just one variable, and no attempt is made to provide a complete explanation or account of all of the possible ways in which the outcome of interest can occur, and no attempt is made to evaluate the relative importance of the many competing explanatory variables. Before going any further, I want to recommend a piece of reading that will fill in many of the details about the effects of causes view that I will inevitably just skim over in this lecture. This is Paul Holland's classic Statistics and Causal Inference, which appeared in the Journal of the American Statistical Association in 1986. This is a very important article and will reward slow and careful reading. In the effects of causes approach, a lot of emphasis is put on gaining a good understanding of how variation is generated in the causal factor under investigation. The simplest case to consider is randomization to treatment and control conditions by an investigator, for example, in a randomized control trial, or RCT. We can think of an RCT as an intervention in nature arranged by an investigator which has a property, random assignment, which makes the interpretation of the outcome particularly straightforward. The investigator manipulates reality, stands back, and sees what the consequence of the intervention is. This way of thinking about things raises several questions. First off, does nature ever mimic this kind of a setup so that we could interpret a purely observational study, that is one where there is no literal intervention or manipulation by the investigator, as if it were analogous to an RCT? The answer to this is yes, to a fair degree of approximation, and I've already mentioned earlier on an example, the US draft for the Vietnam War, as a way of studying the consequence of military service for wages. Secondly, what kinds of things in this view can sensibly be regarded as treatments? This sounds like an odd question to ask, but pause and think about it. A key component of this approach is the idea of a treatment as an intervention. An intervention is like a switch that can either be turned on or off according to the choice of the investigator. Some things we might like to regard as treatments appear to have this quality, while others don't. Any given individual can either be given the new drug or the placebo, the new teaching method or the old, the job training program, or some other activity to fill in their time. However, there are some types of things which do not fit so easily into this schema. Take, for instance, sex or race. It's not obvious how we could randomly assign these to living human beings in order to understand the causal impact of being male or female, black or white, on some outcome of interest. The problem is not unique to the social sciences. A meteorologist may be very interested in the causal impact of the Rocky Mountains on the weather systems of North America, but she cannot arrange for the Rocky Mountains to be both present and not present in order to gather evidence about her causal claims. Holland is quite clear that the kind of causal inference he is interested in requires the possibility that cases could, at least in principle, be exposed to either the treatment or to the control condition. The implications of this view are gone into in greater detail in articles by Holland himself and by Greiner and Rubin, which I recommend to those of you who want to know more about the issues that are at stake. I want now to spend a little time talking about the classic randomized control trial, viewed in many disciplines as the gold standard of empirical causal inference. I'm not doing this because RCTs are a common research design in sociology. Though they are becoming more popular, particularly in policy-related areas, they remain the exception rather than the rule. Most of empirical sociology does the best it can with observational data. However, the RCT does play a touchstone role in the evaluation of purely observational investigations. In essence, we often ask ourselves how closely the design we are, by the circumstances, forced to adopt approximates the ideal RCT. The classic RCT has three features.